Alright, so we've read that paragraph, we've pulled the numbers and decided what variable they were. So the one thing that we don't know is the number of monthly payments. Now, this does say that we want to figure out the fewest number of whole years, so circle that. Keeping in mind that n is a number of monthly payments, so we're going to have to kind of adjust a little bit at the end when we get there. And also they say no more than 720. Right now, if we use exactly 720, that's fine. We're going to find the exact number of monthly payments necessary, which might not be a whole number, and we'll adjust for that at the end. But for now, we're just going to plug in what we know for everything. So M is 720, P is 120,000, R is 0.048, we put that over 12. 1 plus 0.048 over 12 again. To the nth power, we don't know what n is. All divided by 1 plus 0.048 over 12. To the nth power, again, we don't know what n is, minus 1. Well, that's not very pretty, is it? Let's clean it up. Okay, in our numerator we have a number, times another number, times something being raised to the nth power. So I can't really do much with this because it's being raised to an nth power, but I can multiply these out. So I'm going to do 120,000 times 0.048 over 12. And that all ends up being 48. This whole section here, 48. That's nice. And even though I can't multiply it by the parentheses, I can simplify what's in the parentheses, right? 1 plus 0.048 over 12. And that gives me 1.004. And that's raised to the nth power. Are we all okay with the fact that we are not allowed to multiply 48 by 1.004? Oh, what'd I miss? I put 12,000 and not 120. Okay, so that was 480. Thank you. Oh, that would have been a shame. You'll see by the time we got through this, if we had gotten that all wrong because of that one thing, you can never be too careful. Divided by. Again here, we can simplify this base. 1 plus 0.048 over 12 is 1.004 again to the nth power minus 1. So what type of equation, let's wrap our head around this, what type of equation is this? Linear? Yes or no? No. Quadratic? Is it a variable squared? No. What is it? The variable is where? In the exponent. So this is an exponential equation. Now, this is tough because what do we use to solve exponential equations? Logs. The problem is this might be the first problem we've ever come across where we have the exponent variable in two different locations. So what I'm about to teach you is a new technique, okay? So first and foremost, because we have a fraction, I'm going to put this over 1 and I'm going to cross multiply. So that right there is going to be 720 times this binomial, 1.004 to the nth minus 1, equals, and when I cross multiply here, nothing overly eventful, 480 times 1.004 to the nth power. I have to get my 1.004 to the nth power terms on the same side of the equation. I have to. Okay? So, And they were on the same side of the equation already, but they were being divided and there was a binomial involved, pretty ugly. I need to distribute this. Now again, I cannot multiply 720 by 1.004 and get a new number. I cannot do that, because 1.004 has an exponent. So I have to just be comfortable enough leaving it like that. And then 720 times negative 1 is minus 720 equals 480 times 1.004 to the nth power. Okay? I have two terms on my left. Something minus 720 equals something. These are the two terms that both have that 1.004 the nth power in them, which it's going to be clutch for us here in a second that that's the same base, because I'm going to subtract this over. Subtract 720 times 1.004 to the nth. And the beauty is, on the right-hand side, those are like terms. I have 480 of these ugly things minus 720 of these ugly things. So 480 minus 720 is negative 240 of these 1.004 to the nth power. But do you see how that was combinable? If they weren't the same base, I'll tell you what, we have no idea how to do that, so forget about it. But because they're the same base, I can eventually kind of combine them. And now it's a traditional log problem. What do I have to do first? Divide that negative 240 away. That's going to give me 3 on the left-hand side. Well, that was beautiful. And now what do I do to both sides? Log. So I get the log of 3 equals, remember that exponent now comes out in front, n times the log of 1.004. And to get n all by itself, Morgan, what do I do? So n will equal. Now n stands for what? Remind me, Kaylee. Okay, so we're about to find out the number of monthly payments that we would have to make if we were paying exactly 720. So log of 3 divided by the log of 1.004 on a calculator gives me 275.2. Okay? That's how many payments I would have to make if I was maximizing my monthly payment of exactly 720. Remember, 720 is the maximum. I can pay no more than 720. So obviously I can't make that exact number of monthly payments, right? If I need my monthly payment, it can't go over 720. So it's not like I can up the amount that I'm paying per month.
That's 10 months, correct?
If that has to come down a little bit, if you have to make a little bit less than a $720 payment, what's going to happen to the number of months you're paying for? It's got to go up. If your monthly payment comes down, then the length of time it's going to take you to pay it off is going to go up. So we actually need to put that up to the next whole number. Yes? So that would be like 276 months. And the question said the fewest number of years. How do I figure out how many years that is? Divide by 12. 276 months divided by 12 months per year gives me 23 years. Now, I'm going to keep my fingers crossed that there's nothing on the Regents exam that's that nasty. There will be a mortgage problem. That's not necessarily the nasty part. It's the way in which we had to solve for n, which was in 2 different exponents. That's what was nasty about it. Not to mention the conversion from the months to the years, and not to mention the fact that it was no more than 720. Just a nasty problem. This, though, was something that New York State released as a sample question prior to the first year of actually giving the exam. So we were a little bit nervous when we saw that. The mortgage problems we've seen since then have not been that difficult. They're not easy regardless, because it's just a gross formula. Okay, it's not a nice formula. But I will say that you might not always be solving for n. You might be solving for the rate, in which case it wouldn't be an exponential log question anymore, right? Or they might have you solve for your principal or something of that nature. So just, you got to read carefully into any word problem and decide what numbers go in for what variables, and then, you know, start cleaning it up and figuring out and categorizing, like, which kind of equation is this, okay? Hopefully that's the worst you ever get. All right, on the back, let me see, I'm going to pick one of these. I'm going to see. Let's look at number 1. Suppose you can afford a monthly payment towards your mortgage of $1,020. Anthony, what can we take from that sentence?
The mortgage is $1,020.
Okay, so what variable is that? M. Monthly payment, $1,020. What is the most expensive house you could afford, assuming the down payment was already made, with a 30-year mortgage at 3.75% annual interest? Jake Phillips, what can you extract from that second sentence?
You get the months in rate.
Okay, so what is the months?
I don't have a calculator.
Okay, what would you type into the calculator? 30 years times 12 months. Very good. 360. So N equals 360. 3.75%. That's an R of 0.0375. So that sentence packed in 2 pieces of information. And he was good. The N number of monthly payments, 30 times 12, is 360 monthly payments. Excellent. So now we go. 1020 equals, we don't know P. That's what we're looking for. That's the most expensive P, the most expensive amount borrowed for our house that we could grab. 0.0375 over 12, 1 plus 0.0375 over 12 to the 360th power, 1 plus 0.0375 over 12 to the 360th power, minus 1. Never going to be pretty when we first plug in. Never. Okay? But we can slowly start cleaning it up. Now, in this numerator, we can multiply this times this whole thing, because there's no variables involved in this section. So we just have 1020 equals P times, and I'm just going to type in exactly as I see here, 0.0375 divided by 12, get that number. I'm not going to write that down. I'm just going to immediately multiply that by parentheses, 1 plus 0.0375 over 12 raised to the 360th. So that whole numerator number, eek, not pretty. I'm going to write down a lot of that. I don't want to throw anything off by not writing that down. So 0.00960888075 over. And then my denominator is just, again, I can plug that in, parentheses, 1 plus 0.0375 divided by 12, close your parentheses, raise it to the 360th power, and then subtract 1. Also a disgusting decimal, but I'm going to copy that down verbatim, 2.074818395. Now, how do I get P all by itself? Multiply the denominator away, so I'm going to multiply by 2.07 yada yada on both sides. Now on my calculator, I've got that 2.07 stored in there. And I want to use that exact number. Even though I wrote down the whole thing, I still chopped off some of it at the end, because the calculator chopped off some of it to fit it. Calculator screen is only so big. So that number times 1020 gives me 2116.314763 equals P times the .0096 number. And then I'm going to divide by that .0096 number. Keeping in mind that even though I'm chopping it off to write it, when I go to my calculator, I'm going to divide that previous number, 2116, by, and I can go right back up and I can select that .0096 number and bring it right down. And then hit enter, and I get 220,247.39. Now that I will round to the nearest penny. That is the most expensive house I can afford. Okay? I want to show you one question from